Let's take a look at density. We're going to be able to apply concepts of density based on area and volume in modeling situations. The definition can be viewed as the distribution of quantity, such as mass, energy, population, per unit of measurement, such as volume, area, and length. Our first example, New York City has a population of 8.6 million people. If the population density is 27,000 people per square mile, how big is the city in square miles? So the equation we're going to be using is the population density is equal to the number of people over the area. We know the density is 27,000, and it's going to be equal to 8.6 million people divided by our unknown in square miles. We are then able to solve this by putting 1 underneath 27,000 and cross multiplying. So we would get 27,000 times your variable miles squared is equal to 8.6 million people. We would have to divide 8.6 million people by 27,000 to figure out how many square miles this would take up. So when you plug that into your calculator, you would get 319 square miles. Now, if you're plugging this into your calculator, don't forget to write out 8.6 million, which would be 8600 and then 3 more zeros. So you're going to be doing 8,600,000 divided by 27,000. And that's where the 319 comes from. Our second example, we're going to take a look at a blueprint for a rectangular house with a scale of 1 to 40. They give us the perimeter of the house is 100 inches on the blueprint, and we have to figure out the actual perimeter of the house. And once we find that, we have to figure out 2 possible lengths and widths of the actual house. So we are comparing 2 things, blueprint over the actual house. And we know the scale is 1 over 40. They give us the house on the blueprint is 100 inches, so that would go in the numerator, over the actual house perimeter. So we would cross multiply, you would get the actual house perimeter is 4,000. Now, we have to figure out actual dimensions that could possibly be acceptable for this. So if I have a rectangular house, you have to think about perimeter where you're adding the sides together. So for example, you could have, well, it can't be 10, 10, 10, and 10 because it's rectangular, not necessarily a square. So let's do something a little bit more creative. You could do 5,000 and 5,000, which would be 10,000. And if you subtract that from 40,000, you get 30,000. Well, if I divide that by 2, I would get 15,000 and 15,000. So one example of dimensions could be 5,000 by 15,000. Okay. Number 3, we have the density of copper is 8.96 grams per cubic centimeters. The mass of a piece of concrete is 12 grams. What is the volume in cubic centimeters? So they tell us the density. So it's going to be density equals mass divided by volume. The density is 8.96 is equal to the mass, which is 12 grams, over, well, we don't know the volume, so I'm going to call that V. We can always, again, cross multiply. So you would have 8.96 V is equal to 12. You would divide 12 by 8.96, and you would get 1.34 cubic centimeters as the volume. Number 4, we have a gumball machine, spherical glass section that holds gumballs, which is also spherical. They tell us the diameter of the sphere is 20 inches, and the radius of one gumball is 0.2 inches. How many gumballs will fit in the machine? Well, we have the volume of the larger sphere, okay? And we have to figure out the volume of the gumball. And when we know the volume of each, then we can divide the number of gumballs into the sphere. So the sphere would be 4/3 pi r cubed, and the volume of the gumball sphere, again, is 4/3 pi r cubed. And now we plug in the actual value, so you'd get 4/3 pi. Well, the diameter of the larger sphere is 20, so that would give us a diameter of 10, so it'd be 10 cubed. And when you plug that into your calculator, you would get 4,188.81. Now, if you do the volume of the gumball, the radius for that is 0.2 inches. And then we have to cube that. When you plug all that in, you would get 0.03 cubic inches. So we have the 4,188.81 divided by the 0.03, and that will give us the number of gumballs inside of that machine. So that would come out to 139,626 gumballs. A study reports that in 2010, the population of the U.S. was 308,745,538 people, and the land area was approximately 3,531,905 square miles. So we have to find the population density in people per square mile of the U.S. in 2010. We're using the formula density is equal to population over the area. And we don't know the density. That is what we're solving for in this case. We know the population was 308,745,538, and we have to divide that by the square miles of 3,531,905. When you plug that in, you would get 87.4 people per square mile.